Hi there everyone, in this video we are going to be going through some solving equations using logarithms. So one of the things I said in the video right at the start of this series was how useful logarithms were in trying to solve equations where the variable, the thing you're trying to find, is a power. And as you see here, it's because of this log law whereby when we do have a power and we take the logarithms, this number comes down the front here. So that makes it really easy to solve these equations. So we no longer just need to use a calculator that has the function to be able to solve something. We can solve these things exactly. So the method here, we're going to take the logs of both sides. We'll talk about natural logs in the next video, but we can take the logs of both sides, use this idea of putting the number down the front, divide the logs, and then we're going to solve. So I'm just going to do a few examples here to show you how this works. Okay, so we've got 2 to the power of x is equal to 23. So what I'm going to do, and of course you could solve this just using your calculator, no problem, that's easy, just use the solve function, but I'm going to use the old calculator here to get some logarithms going. So what I'm going to do is take the log of both sides, so log 2 to the power of x equals log 23, okay. So remember, the x will come down the front. That's the third log rule. So I've got x log 2 is log 23. And at this stage, guys, it's important to know that the base here doesn't really matter as long as we use the same base. Now on our calculators, there's 2 buttons for logarithms. There's a log button and an ln button. So I'm going to use either one. It actually doesn't matter. I'm going to talk about the ln button in the next video, but I'm going to use the log video, which is log base 10. So here, if we do, we're doing log base 10 of each of these. But as long as they're both the same, it doesn't matter. So therefore, we're going to divide to find x now and say x is log 23 divided by log 2. Now this is very important to know that this is not the same as log 23 over 2. That one there would be log 23 minus log 2 using the second log law, but it's not the same as log 23 divided by log 2. Sometimes people get those two confused. So let's not do that. Okay, so I'm going to grab the calculator now. Log 23, divide that by a log of 2, and I get 4.52, 3 sig figures, okay, or 4.524. I'll just go to 3 significant figures. Okay, that's x. So that's how you solve your first basic logarithm equation. Gets a bit trickier in B. I'm going to do the exact same thing though. Take logs of both sides. Log 2 to the 5x minus 1 is log 3 to the x. Okay, now just be careful when you're bringing this thing down, the whole thing has to come down the front. So that 5x minus 1 put in brackets and put the whole thing down the front. So I've got 5x minus 1 log 2 is x log 3. Okay, bit of expanding. This one's a little bit trickier. I mean, you could do some expanding, or you could divide the logs first. There's a number of different ways of doing this one. I think what I'll do here is I'll expand it first. So I've got 5x log 2 minus log 2 is x log 3. Now what I'm going to do is get everything that's got an x in it on one side and everything else on the other side. So I'm going to put this log 2 over here, and on this side I've got 5x log 2, and I'm going to subtract x log 3. And you'll see while I'm doing this, because then I can take out x as a common factor. 5 log 2 minus log 3, and this is equal to log 2. So x, the thing I'm trying to find, is log of 2 over 5 log 2 minus log 3. So in the exam you may be asked to write the answer to something like this in the non-calc section exactly, so without using your calculator. So there's the answer. This question here is asking me to give the exact answers involving base 10. So I could leave my answer like that. And the first one there, I didn't need to do this step here. I could have just left it at this step here. So I'll leave it exactly like that. Now you could, if you wanted to, remembering the last video, say that 5 log 2 is actually log 2 to the power of 5, which is log 32. Okay, and then on the bottom line you could say that's log 2 over log 32 over 3. Okay, I know you can't simplify it anymore. You can't log 2 over log whatever that is, 10 and 2/3. You can't simplify anymore, so that's fine as well, or you could just leave it as that first step there. Okay, let's check this one out. A little bit trickier than the other ones. I'm going to do the same thing. Log 3 to the x, 2 to the x minus 1 equals 8. Okay, same for, log 8. Taking logs of both sides. So as long as we do the same thing to both sides, we're all good. Cool. Now remember the log law that says log AB is log A plus log B. So I'm going to apply it here. So this is going to be log A plus log B. And again, I'm kind of working in base 10, but it doesn't matter. I'm only working in base 10 because my calculator, when I hit the log button, that's base 10, so it makes it a bit easier. Now I'm going to apply that third log rule, where the things that we want to find come down the front, which is extremely handy, as you can see. There we go. Cool. Now I'm just going to do the same thing I did in the last video, is get all the x's on one side, all the other stuff without x's on the other side. So I've got x log 3 plus x log 2. When we expand this bracket, we'll get minus log 2. So I'm just going to add that to the other side. Log 8 plus log 2. Cool. So I've got x log 3 plus log 2 equals log 8 plus log 2. And you could start doing some simplifying now. This is log 3 plus log 2 is actually log of 6. Alright, log AB is log AB, yep. Log A plus log B, and log 8 plus log 2 is the same as log AB is log A, so we know this is log 16, right? So x is log 16 over log 6, and that, remember, is not log 16 over 6, different thing, so I can't subtract those. That is the simplest way you could write that one. You could then get your calculator out and work out what that was exactly if you have to. But again, you could be asked what's the answer to that and leave it in that form like that. Okay, let's check this one out. In this one here, it's a little bit different because we've actually got log in the expression to start with. So the question is, how do you undo a logarithm? How do you undo? Just we know if we've got a squared function, we know to undo that we square root. We know if we've got a square root function, we square that. We know if we've got 2x, to undo that we divide by 2. So here it's just understanding the inverse functions for logarithm. The inverse function for log base 10 is 10 to the power of. That's the thing that undoes the logarithm function. So what I'm going to do here is go 10 to the power of both sides. And that's going to undo it. So 10 to the power of log base 10 x plus 2. Let's just going to focus on the left hand side. 10 to the power of and log base 10 are inverse functions. They undo each other. So I'm just going to end up with x plus 2 over on the left hand side. Okay, 10 to the power of log base 10x plus 2. It's really important that you don't do 10 to the power of each of those individual terms. No good. You've got to go 10 to the power of the whole side. Because as you see here, this is 10 to the power of log base 10x times 10 to the power of 2. Right? Remember, if we're multiplying, let's just look at this step here. If we're multiplying, we've got to add the indices. So you can see, if you think of it that way, that leads to that step there. So you've got to be real careful in that one. Okay, so what do we end up with here? We've got x plus 2. 10 to the power of log base 10x is just x, and 10 squared is 100. So now we've got a really easy equation to solve. 99x equals 2. X is 2 over 99. So again, you could solve that equation in the non-calculator section. I'm not using my calculator here because it's pretty easy to do on your calculator. So I expect to maybe see some of these solving logarithm equations in the non-calculator section, which tests your algebra skills to be able to do this taking logs of both sides things like I've been showing you.